Okay. Welcome back. This video is going to be for advanced math. This is probably the only video I think we'll need on section 4-3, but we'll see how long it goes. You can see the topic up here. We're going to begin talking about the concept of what is a logarithm? What is an expression with a logarithm in it? What is an equation with a logarithm in it? And I'd actually like to start with this. I'm going to write just kind of an equation up here. It's not going to have a logarithm in it or anything. I'm just going to write 2x equals 8. Okay. Now that's an equation, right? It has an equal sign. This says that this expression is exactly equal to this expression. Teddy, do you want me to start this over, or do you want to get out of my way?
Fine.
Okay. Hey, no, Teddy. Hey, I love you, boy. Come give me a kiss. Oh, a dinosaur puppet? Good boy. I love you. All right. So, this is an equation, and what I was going to do is I was going to actually change the appearance of this equation, and I'm going to write this. I'm going to write x equals 8 divided by 2. All right. Now, I think we can all agree that this equation shows exactly the same relationship between the three symbols here, the 2, the x, and the 8, as this one does. Okay, the 2 times the x is equal to the 8. That's exactly the same relationship between 2 and x and 8 as this is. X is equal to the 8 divided by the 2. Okay, one more maybe simple example just to drive home this point. If I have x plus 2 equals y. I have three symbols again, the x, the 2, and the y. And the relationship between x and 2 and y is shown here. If I take the value of x and add 2, that gives me the value of y. Well, I could conceivably rewrite this as x equals y minus 2. Now, the appearance of that second equation is different, but the relationship between the three symbols is exactly the same, between the x, the y, and the 2. So I mention all that because to introduce the concept of what a logarithm is, I think it's important to understand the concept of equivalent equations. And this equation is exactly equivalent to this equation. Yeah, I see you. Thank you, Teddy. You're a good friend. All right, now, excuse me. Let's begin by just writing a logarithmic equation here. I'm going to write log base b of a equals c. Okay, now I have three constants up here. Okay, the b is a constant. That means the b is going to represent a number. The a is a constant, and the c is a constant. And this is an equation that relates those three constants. Now, this mathematical expression log, okay, or logarithm, or just log, that's an operation. Okay, much like sine is an operation. I can write sine, but just by itself, it really doesn't mean anything until I put an argument here, like sine of, say, 30 degrees. Now this expression has meaning. Same way with a logarithm. Unless I have an argument here, it doesn't really mean anything by itself. So now, let's look at this equation. And I want to, what I want to do is just kind of name the three pieces of this equation. So this little number right here, that's called the base of a logarithm. This is called the argument. That's the number or other expression that we are taking the logarithm of. Okay, and this right over here, this is the exponent. Okay, so logarithm itself is an operation. a logarithm has to have a base in order to have meaning, okay? And you take the logarithm of some mathematical expression called the argument, and the result is an exponent, okay, which will either be a number or some other mathematical expression. Okay, now let's see how this works with some numbers. I'm going to write log base 2 of 8. Okay. Now notice I don't have an equal sign yet, but I'm taking the logarithm to base 2 of the number 8. And the result, remember this is the base, this is the argument, and over here what I should get is an exponent. Well, how do I figure out what that exponent is? Well, here's how. Again, I'll watch carefully if you've forgotten how to do this. Base raised to an exponent gives you the argument. So what I have to ask myself to figure out what goes, or what number goes over here is 2 to what power would give me the number 8? Okay, well let's see, 2 to the first power is 2, 2 to the second power is 4, 2 to the third power, 2 to the third power is 8. So 2 to the third power gives me 8, and that completes my logarithmic equation there, okay? This says, okay, that the log to base 2, okay, now notice how I'm saying that. I'm saying log to base 2 of 8. Now, it's perfectly acceptable to say log base 2 of 8 equals 3. Either way is fine, but that's what this says. Log base 2 of 8 has a value of 3. Now, another way to write the same relationship between the three numbers 2 and 3 and 8 is this. Well, I mentioned that this base raised to this power has to equal this number right here. So I can write it that way. So I can write the base raised to the third power, in this case, equals my argument 8. Okay, now, how many equations do I have on the board now? 1, 2. Okay. Those two equations are equivalent equations. They each show the same relationship between the three numbers 2, 8, and 3. This is in logarithmic form. This equation is in logarithmic form. This equation is in exponential form. They are equivalent. They show the same relationship between the three numbers. Okay. Now, one of the tasks that you'll be doing in the 4-3 assignment is to take an equation that's written in one form and transfer it into the other form. So if you're given a logarithmic equation, you can take it into exponential form, and if you're given an exponential equation, you can take it into logarithmic form. So maybe we'll do one of each. We already kind of did one. Let's say I had 5 to the 4th equals 625. Okay, that's an equation that shows a correct relationship between the numbers 5, 4, and 625. 5 times 5 times 5 times 5 will give you 625. Okay, that's a correct relationship. Now, this is written in exponential form. A base raised to an exponent gives me a number. To write this in logarithmic form, okay, well, I know that this is my base, okay, because that's the base of an exponential expression. I know that this is my exponent, so this must be my argument in a logarithmic expression, or equation, sorry. Okay, so the way I'd rewrite this equation in logarithmic form is this. I'd write log base 5 of 625 equals my exponent, which is 4. Okay, 5 to the 4th power gives me 625. So this equation and this equation, they're equivalent. One is in exponential form, the other is in logarithmic form. All right, maybe we'll do one the other way as well.
You're at 10 minutes.
All right, thank you, boy. Let's do this. Log base 3 of 9 equals 2. All right, and I think you'd agree with me that this is a correct, that this equation shows a correct relationship between the numbers up here. 3 to the second power equals 9. And to rewrite this equation in exponential form, well, I can write 3 to the second power equals 9. And you'd agree that that is also correct. 3 times itself is 9. Okay, so that's kind of the first task that you'll be asked to do. Now, let's talk about maybe some other issues that come up when we're dealing with logarithms. Let's do this. Log base 7 of 1 over 49. Okay. Now, I don't have a complete logarithmic equation up here. Mr. Dinosaur, I hope you're not getting in the way of the board. Okay. All right, thank you. I haven't completed the logarithmic equation because I want us to kind of think about this together. This has to be an exponent over here. And it had 7 raised to this power has to equal the number 1 over 49. Now, please just remember, all right, that what a negative exponent means. Okay, I know that 7 to the second power would give me 49, but my argument is not 49, it's 1 over 49. So, I think, well, if 7 to the second is 49, 7 to the negative second is 1 over 7 to the second. So the exponent we need right over here is going to be a negative 2. Remember that 7 to the negative second is the same as 1 over 7 to the second, which is indeed 1 over 49. Okay, so if I have the logarithm of a fraction, okay, where the argument is a fraction, oftentimes the answer over here might be a negative number. Okay. Now, how are we doing time-wise there, boy?
12 minutes, 30 seconds.
Yeah, we've got time for another one. Let's do this. I'm going to write log of 1,000 equals. Now, what appears to be missing in this expression? Well, obviously the exponent over here is missing, but there's also no visible base, okay? So let's talk about that. If there is no base written, then it is base 10, all right? A logarithm with base 10 is called a common logarithm, okay? I'll say that again. A log with base 10 is called a common logarithm. That's just what they're called. And if you're going to write an expression with a log base 10, you don't have to write the 10, okay? You don't write the 10. The whole world will assume that you mean that this is base 10. So now I think, okay, well, what does my exponent have to be? 10 to some power has to give me the number 1,000. Well, I think it's 10 to the third power that would give me that. And to rewrite this equation in exponential form, I take my base raised to my exponent and set it equal to my argument. And that's also a correct equation. Now, do we still have a couple minutes here, boy?
You're at 14 minutes.
All right. I tell you what, I think we can finish this up. Let me show you the other type of logarithm that's a little bit, that doesn't have a visible base. Log with a base of e. And if you remember, we talked about the number e in 4-2. You'll never see this written, okay, a log with a base of e. Because a log with base e is always written as ln, or a natural logarithm. Okay, there's a button on your calculator for natural log. It's on the left-hand side, third from the bottom. And so if I have something like this, if I have like natural log of, say, e to the second, and I want to figure out what goes right over there. Well, okay. The base of a natural logarithm is e. So my little base e here that's not visible, right? E raised to some power has to give me e to the second power. Well, e to what power gives me e to the second power? Well, that's pretty simple, right? E to the second power gives me e to the second power. Okay. Where are we, Teddy?
15 minutes, 30 seconds.
Okay. You know what? I think we can probably stop there. I think this is plenty of discussion about just simple logarithmic expressions and translating between exponential form and logarithmic form with equations. You know, obviously, if you have a question, if you want to send me a picture of your work, like always, that's going to be fine. But for now, we'll sign off. Thanks for watching.